Okay, so first things first, the general equation for the straight line is this, right? Y equals to mx plus c. Now, there are two important parts over here that we do need to know. First of all, the slope. You already know the idea of the slope as having as rise over run, right? It basically tells you about the orientation of the line. Is the line going up, down, and if it is going up, to what degree is it going up, right? The number of the slope, whatever slope you get, basically represents the idea. So, for example, if you have a slope of 2, if another line has a slope of 3, the line that has a slope of 3 basically tells you that it would be much more steeper than the line that has a slope of 2, and that would be less steep. Okay, so that's what the idea of the slope represent. There is a formula for the slope also, which is y2 minus y1 upon x2 minus x1, right? So in this case, basically, if you have the y values, if you pick up any 2 points, okay, so I'm representing those points as x2 and y2 and x1 and y1. What you are doing is by taking out y2 minus y1, so basically saying what is the difference between the y coordinates of those 2 points, which is going to be basically this thing, right? So y2 minus y1, which also represents our rise, correct? So that's rise. And then when you do x2 minus x1, you are saying what is the difference between the horizontal difference between the two x coordinates, right? So that's what represents x2 minus x1. This is also represented by what we call the run. Okay, so that's what the overall um, equation or overall idea of slope represent. Okay, that's for first thing. Secondly, the y-intercept is supposed to be that coordinate of y when the line touches the y-axis. So you can just, if you have the graph, you can just look it up. Okay, whatever y value you get when when the graph, when the line or curve or whatever you have on your graph touches the y-axis, that's going to be a y-intercept. Okay. So let's practice, I'm figuring out the slope and the y-intercept over here. Now, first of all, we have, let's go ahead with the slope. Okay, we already have seen the formula. It is y2 minus y1 upon x2 minus x1, where these essentially represent some points on the graph. Okay, so we will have to pick 2 points. That's the first thing you will do. In order to calculate the gradient, you have to pick 2 points so that you can come up with your y2, x2, and everything. So let's just pick any convenient point that you can clearly see, easily point out on the graph. Okay. So for example, let's say I pick up this point. Okay, this point. Now let's try to read the coordinate of this. It's going to be, so since I can see that these are like, 5 boxes, right? So one, two, three, four, five, and I can see the five clearly labeled over here. So I know that for each box, we have 1 unit increase in the x coordinate, right? So according to this point, the x coordinate would be 2 over here, right? And then as far as the y coordinate is concerned, well, it's quite another similar 1, 2, and 3, and 4. So as you can see, the y coordinate would be 3 over here. Okay, I'll get rid of the other points. So you should be able to easily read these points, easily read these coordinates. And remember, your coordinates are written with x coordinate first, so 2, and then y coordinate followed by that. Okay, all right. So this is how you represent it. We call these ordered pairs. Okay, you write down the x coordinate first, and then you write down the y coordinate. Always remember that. So this becomes our x1, okay, and this becomes our y1. Okay. Now, let's pick another point, another convenient point, because remember, in the formula, we need two x values and two y values, right? So we have one right now. We have to pick another point. So let's pick, for example, let's pick this point. Okay. So over here, as you can see, the y coordinate is what? Y coordinate is 5, and sorry, that's the x coordinate. X coordinate is 5, and the y coordinate, as we can see, it's going to be 9. That's just one step before 10, so that's going to be 9, right? So this is now going to be called our x2 and y2. Okay. Now let's recall the formula. It's y2 minus y1 upon x2 minus x1, right? So let's first copy that formula. Y2 minus y1 upon x2 minus x1, right? So our y2, as we can see, is 9, correct? Minus y1 is 3, divided by x2 is 5, minus x1 is 2, right? So we get 9 minus 3, that's going to be 6. 5 minus 2, that's going to be 3, right? Now we can um, we can divide these to get 2 at the end. Okay, so our slope, that means it's going to be 2. So we have answered this first part, right? Now let's get to the y-intercept. Remember, what was y-intercept? It is the coordinate of y, so it's going to be some coordinate of y when the line touches the y-axis. When the line touches the y-axis. Let's see where that is happening. So this is our line, right? We have to see where it touches the y-axis. Remember? Sorry for that. Remember that this is our x-axis, right? And this is our y-axis, right? So where does this line touch the y-axis? It's this point, right? It is this point where the line touches the y-axis. So let's highlight that. So, and again recall, it is the y coordinate when the line touches the y-axis. That will be our C, the y-intercept. Okay. So we have highlighted the point. We are supposed to read the value of y coordinate at that point. Okay. And what is the value of y coordinate at that point? Well, it's just one step below 0, right? So that's going to be -1. Okay. So this means that our C is going to be -1. That's all we need to do. So our C is -1 and our M is supposed to be 2. Okay. Now your next job is to um, go ahead and solve this question.